Okay, so I have applied the capacitor here, and I open up the back of it so it can exit in open clearance, so it can exhaust its ions so it can intake more heat. This is a 450 watt capacitor, 450 volt capacitor. I had it coupled and attached to a coil, a helix coil, that is a magnetic wire that is covering a non-coated copper wire. And on top of the coated copper wire, there is a spun metal iron wire to increase the flux of the coil. In this housing, there is a permanent magnet. The permanent magnet sends a Hall effect along with the induced currents of the electrodynamics Hall effect to synchronize this tubuloid type transformer that I made around here and of the gauntlet. And I also added a series of copper coils for suspension following this way. So the current hopefully is more than the current that is given. So both of them share currents and current back and forth. The vortex of this turning and rotating at high speeds, at least at 40,000 RPMs. So here I have a bridge rectifier, which is about 400 amps. And I have under here Capacitor module. I have here capacitor motor controller and single phase. I have also Capacitor block coolant here, and also localized alongside the back here. I just didn't add the tubings here because I'm going to use aluminum tubings to circle around the area and to at least cool it. And I was going to have it like spray at least an antifreeze locally on the side to cool it. Nevertheless, I phased the wires all into a two-way transformer. I have aluminum wire coil that is right local to the copper coil surfaces that are like a solenoid linear motor. I have, well, that's exactly what it does. So it will transmit the voltage back to here and cause this to move backwards. I have an iron surface. I have flux coils, iron coils spun around the coils that are underneath this rubber coating. So I coated it with rubber, and it's just a test unit to test to see how far it goes. The plug-in module that I'm going to use to attach it to here will connect all these wires into the bridge rectifier. The DC side output. Nevertheless, the AC side input, I can use a booster. Not a booster. I can use a dimmer with a nice polarity modular. So just a nice voltage, like 10,000 volts or less. But I don't have to use that much voltage with this. So the primary thing is just to get this started. Then I'm going to add a sheet of aluminum. I'm going to send a copper, and I'm going to send aluminum. I'm going to send a current to it. The aluminum has to be up the top in order for it to move backwards. The entire coil away from its inertial mass, away from the mass of the coil, or the sheet, vector field, aluminum sheet. The copper sheet must be in the back. So because they're in a magnetic field, they will share current. The copper sheet will also have DC phased, and the aluminum sheet will also have DC phased. So I'm going to phase those also into the current with the metal bond ground, the cathode out, so that the electrical field will not have to synchronize in order to move it away. As soon as the coil gains current and both are within the magnetic field, this entanglement will cause repulsive force away, and because of the repulsive force of the common, both of these positive charge matter will move away from one another. So the copper will escape the aluminum top enclosure, and the copper sheet that's under will also escape the aluminum sheet that is on top. So that's how that is to work, to go back and back twice, pushing away the copper sheet that's in the cockpit, at the same time the copper coil escaping from the aluminum sheet that is on the enclosure, while at the same time simultaneously the rotary adds current and the force to induce currents to the coil, and the force away is a repulsive force away, having this exhibiting this to create a common microwave so that it will force it away, moving at 4,000 RPMs. That's what I'm up to for the hand unit test of this one, which is just one hand unit test that I'm going to do, and so it fits in my hand, and just to try it out there, see what I can do.